For this lesson, we will be going over center of gravity and centroid. Let's look at some of the learning outcomes. First, we want to understand the definition of the center of gravity and centroid. We also want to learn how to find center of gravities and centroids using horizontal or vertical strips. The center of gravity is a point where a single resultant weight can be applied to replace the weight of all particles in the body. This graph shows where the center of gravity would be in this particular shape, where x squiggly and y squiggly are the coordinates of a particle in the body and dw is the weight of the particle. We can then find the coordinates of the center of gravity using these equations. X bar is equal to the integral of x squiggly dw over the integral of dw, and y bar is equal to the integral of y squiggly dw over the integral of dw, where x bar and y bar are the coordinates of the center of gravity. Because the weight and mass differ only by a constant factor g, the centers of mass and gravity coincide in most applications. Differences rise only in problems where the gravitational field is not uniform. This graph shows the center of mass of this particular shape, where x squiggly and y squiggly are the coordinates of a particle in the body and dm is the mass of the particle. Similarly to the previous slide, y bar and x bar are just going to be the integral of the coordinate of a particle in the body, dm over the integral of dm, where x bar and y bar are the coordinates of the center of mass. The centroid is the geometric center of the region. Centroids and mass centers coincide only if the distribution of mass is uniform. This graph shows the centroid of this particular shape, where x and y are the coordinates of a particle in the body, and a is equal to the integral of dA. These would be the equations used to find the coordinates of the centroid, where x bar and y bar is equal to the definite integral of the coordinate of a particle in the body dA over the area. X bar and y bar are the coordinates of the centroid. dA will equal dx dy in this case, which means we will need to use a double integral. We can also use alternative methods such as horizontal strips to avoid using the double integral. Using the equations from before, we can replace dw with x dy, x squiggly with x over 2, and y squiggly with y to get these two equations, where x bar is equal to the integral of x over 2 x dy over the integral of x dy, and y bar is equal to the integral of yx dy over the integral of x dy. We can also use vertical strips. Using the same equations from before, we can replace dw with y dx, x squiggly with x, y squiggly with y over 2 to get the following equations, where x bar is equal to the integral of xy dx over the integral of y dx, and y bar is equal to the integral of y over 2 y dx over the integral of y dx. Let's take a look at this example. Determine the area and the centroid x bar y bar of the area. The easiest way to solve this example is by using vertical strips. First, we need to calculate the area. Notice that the vertical strip is in between y2 and y1. This will give us a dA of y2 minus y1 dx, which is x minus x cubed over 9 dx. We can now solve for the area using the definite integral of dA, which is the definite integral from 0 to 3 x minus x cubed over 9 dx. This will give us an area of 2.25 feet squared. We will now need to establish x squiggly and y squiggly. X squiggly will just be x, and y squiggly will be y1, which is the space in between the origin to the vertical strip, plus y2 minus y1 over 2. This gives us y squiggly as 1 over 2 x plus x cubed over 9. Now we could find x bar, which is the definite integral of x squiggly dA over the area that we found earlier, and solving this will give us 1.6 feet, and y bar, which we can use the definite integral of y squiggly dA over the area that we found earlier, which will give us 1.14 feet. Therefore, the area is 2.25 feet and the centroid is located at the following coordinate: 1.6 feet, 1.14 feet. So, for this example, using vertical strips, we were able to calculate the area, which helped us get y bar and x bar.